ladder friction, which is again one of the very important type of friction. जर्नल दिसतंय सगळ्यांना?
Yes, ma'am.
So in case of friction, there are 4 types of friction which I have already told you yesterday, out of which block friction or block friction you can say is a bit familiar. You people are regarding block friction, you have already studied it, but in case of ladder friction there is one change, that is your ladder is having one dimension. कंटिन्यू मला या स्क्रीनवर इकडे हे करायला लागतं. बरं ठीक आहे, थँक्यू. सो I will draw one typical diagram which will give you idea regarding किती झाले 55. Yes. So in case of ladder friction, our consideration is, you know that your ladder is always an inclined member which is resting with the help of vertical wall and horizontal floor. बरोबर का?
Yes, ma'am.
Yes. So if suppose this is ladder, this is standard case I am explaining. So if suppose this is some angle theta which your ladder is making with respect to horizontal, you know that your ladder is normally having its length just a minute, जर्नलला जरा प्रॉब्लेम येतोय, एक मिनिट. I hope it is visible. दिसतंय ना?
Yes, ma'am.
Yes.
Yes, ma'am.
So your ladder always rests with the help of some vertical wall and some horizontal floor. So this vertical wall will obviously provide some simple support to your ladder, which is making some angle theta with respect to x-axis. Length of the ladder I will consider suppose as L. And if in the problem self weight of the ladder, that is weight of ladder is suppose mentioned in the problem, then we can consider that it will act as L by 2 and L by 2, where CG of the ladder will act, and at this point there will be action of this, I will call it as W1 suppose. So this W1 will act, which is self weight of the ladder. There will be some support which will be provided by this vertical wall, which is suppose simple support. You know that any surface provides support to any object which is always perpendicular to the surface. बरोबर का?
Yes, ma'am.
So
Yes,
vertical
ma'am.
wall will provide horizontal support. I will call it as first normal reaction. So I will name it as N1. Your second support,
मॅम तुम्ही W1 L/2 वर दाखवलं का?
yes beta, L by 2. Because this is self weight, this is your length of the ladder. So if ladder is homogeneous, it is mentioned in the problem. If suppose it is not particularly mentioned in the problem, then you can consider that at L by 2 there is action of self weight of your ladder. But in some of the cases, it is given that centroid of the or center of gravity of the ladder is at this much length from bottom point or at this much length from top point. So accordingly, you need to consider that value or that point as centroid or center of gravity, and from that point you will apply this self weight of the ladder. Is it clear?
Yes, ma'am.
Yes. So N1 is vertical wall which is providing horizontal support reaction. Now second support reaction, this floor will provide to the inclined ladder which is now perpendicular to the horizontal surface. As surface is horizontal, vertical will be the support reaction provided by the ladder, provided to the ladder by the horizontal floor. Now if suppose this is a case, can you tell me if some person with some weight, suppose W2, is trying to climb on this ladder, whether he will be able to reach up to this top point? बघितलंय का कधी लॅडर एखाद्या माणसाला चढताना?
Yes, ma'am. He
तो
will.
लॅडर
ma'am.
चढताना, येस, तो लॅडर चढताना जेव्हा तो लॅडर चढत जातो वरती वरती, तेव्हा तो या टॉपमोस्ट पॉइंट पर्यंत जाऊ शकतो का लॅडरच्या?
नाही.
केलंय का ऑब्झर्व कधी?
Yes.
Yes, normally it is not possible. What happens when any person with suppose weight W2 tries to climb on this ladder, maybe up to distance of X meter from this bottom point, or you can say X meter from this top point, he will be able to climb on the ladder safely. But once he will reach to this X meter distance, this ladder will have tendency to slip down. Have you observed this?
Yes, ma'am.
Yes, ma'am.
Now, if suppose this ladder will have tendency to slip, whether it will have tendency to slip inward or outward?
Outward.
Obviously outward. So if expected motion of the ladder on the floor or with respect to floor is outward, can you tell me what should be the direction of frictional force acting on this corner or acting on this end?
Inward.
Inward.
Inward. So it must be opposite to the direction of expected motion. If impending motion is rightward, leftward should be my frictional force. Can I call it as F2, which is corresponding to N2?
Yes. Yes, ma'am.
Yes,
Okay.
ma'am.
Now maximum frictional force which can be provided to this end is mu s into N2, which is F2 limiting, you can say. Same way, when my ladder will have tendency to slip down, which is in the outward direction, what will happen to this top end?
Upward direction frictional force.
येस, म्हणजे ती डाऊनवर्ड स्लिप होणार आहे,
Downward
या
जाईल.
वॉलवर
Yes,
ती
ma'am.
घासत जाईल
Yes,
खाली, बरोबर?
Yes, ma'am.
So it will experience frictional force in the opposite direction of expected motion, that is F1, which is maximum mu s F1. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This is your standard free body diagram for ladder friction, where in some of the cases it can be mentioned in the problem that your wall is smooth. If wall is given as smooth, N1 will be there, but it will not offer any kind of frictional force to the ladder, so this F1 will not exist. Is it clear?
Yes,
Can you
ma'am.
repeat?
Yes, ma'am.
Ma'am, can you repeat?
Normally, you will have in some of the cases, it is mentioned in the problem that your mu s value for floor and ladder is equal to your mu s value for your vertical wall and ladder. So in that case, both your mu s values will be same. But in some of the problems, your mu s values can be different. So accordingly, you need to consider N2 into that corresponding mu s, which can give you maximum frictional force offered by floor or offered by wall. ही कन्सेप्ट सगळ्यांना क्लिअर झाली का? ही एकदम
ma'am.
बेसिक कन्सेप्ट आहे. हे जर समजलं तर आपण प्रॉब्लेम सॉल्व्ह करू शकतो. नाउ यू कॅन सी दॅट ॲज युअर मेंबर इज हॅव्हिंग लेंथ L, W1 is acting at L by 2 from top or even from bottom. W2 is weight of that person who will be able to climb on this ladder up to X meter safely. Okay. So once that person will again climb on this ladder, even he will cross X meter by small amount, what will happen to this ladder? This ladder will lose its equilibrium. Okay. It will lose its static condition and obviously it will move down. It will slip down. So up to this point means this is that last distance up to which your ladder will be in equilibrium. So we can apply our equilibrium conditions. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
can we start with problem then?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes. Chalo, take down first problem. So for the very similar concept, I will just mention you the values which I have written over here. Here in this case, I will read the problem. Just don't write anything. Just given data we will write over here. A 12-meter ladder means my L is equal to 12 meter. That is length of the ladder. Is resting against a vertical wall, making 30-degree angle with wall. Now my angle of ladder is given with respect to wall, which is 30-degree. Static friction between wall and ladder is, now this is wall and ladder. So mu for this is given as 0.3 and that between ground and ladder, here it is given as 0.25. A man of 600 Newton ascends the ladder. How high will he be able to go before the ladder slips? Assume that weight of the ladder is 800 Newton. Whether problem statement is clear to all?
Yes, ma'am.
Yes, ma'am.
Okay.
मॅम पॉईंट
Yes.
3 कशाचा आहे म्यू?
हा याचा बेटा वॉल आणि लॅडर मधला आहे
ओके
आणि हा इथला फ्लोअर आणि लॅडर मधला 0.25. ठीक आहे. सो ड्रॉ दिस सेम फ्री बॉडी डायग्राम फास्ट. आता फक्त व्हॅल्यूज लिहा. इथे अँगल 30 डिग्री लिहा. दिस इज W2, दिस इज W1. Now instead of W2 and W1 in free body diagram, you can directly put these values. Weight of the ladder is 800 Newton and W2 is weight of the person, which is 600 Newton. Your L by 2 is 6 meter and remaining L by 2 is also 6 meter. Free body diagram झाली की सांगा. We will start.
येस मॅम.
Okay,
Done, ma'am.
done.
Yes,
Yeah.
ma'am.
Now we know that this is that position which we have shown in the figure up to which the ladder will not slip and it will be in equilibrium. So can we apply our 3 conditions of equilibrium to this?
Yes, ma'am.
येस मॅम.
Yes.
Yes, ma'am.
Because we know that if you will see all the forces which are acting at different points, their line of actions are not parallel to each other. They are not intersecting at one single point. Means they are representing which kind of force system?
General Coplanar.
General
General
Coplanar
Coplanar.
force system. Very correct. So we can apply our first condition of equilibrium, that is summation Fx is equal to 0. Can you tell me, we will start from this point, how many forces are there which are acting along x direction?
N1.
It is N1 and
N1
any other force
and F2.
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 will be equals to F2. Either you write it as F2 or you can say it is equal to 0.25 N2. Barabar?
Yes,
Yes,
ma'am.
ma'am.
So that you will
Yes,
get
ma'am.
your relation between N and N2. This is your relation. Okay, fine. Equation number 2. Summation Fy will be equals to 0. Now along summation Fy or along Fy, what you are having over here, it will be 0.3 N1, बरोबर?
Yes, ma'am.
Yes, ma'am.
Minus 800, which is self weight of the ladder, minus 600, which is self weight of the person, and plus
Plus N.
N. Okay, this will be equals to 0. But you know that N1 is equal to,
0.25 into.
0.25
yes,
into.
replace anyone in this equation, which is suppose your equation number 2, this is equation number 1, and tell me N1 and N2 काय व्हॅल्यू ते सांगा. कुठल्याही एकाला रिप्लेस करून सांगा.
One three zero two.
Yes, ma'am.
1302.232.
For N1,
32.
N2,
Yes,
ma'am.
N2, ma'am.
N2.
N2.
N2, okay. 1302.433.
33.
32
Yes, ma'am.
newtons, and for N1,
325.58.
5.
किती 3,
325.
325.
okay,
325.5.
325.58 म्हणजे 6 घ्या. Okay, okay, is it clear?
Yes, ma'am.
So
Yes,
now
ma'am.
you are having N1 and N2. We are interested in X. To get value of X, either we need to take movement about top point or about this point. Anyone can give us value of X. So it is as per your choice. सांगा मला कुठल्या पॉइंटच्या अबाउट मुवमेंट घ्यायची आपण.
Bottom point.
Bottom.
Bottom.
About this point, bottom point.
Yes,
Yes,
ma'am.
ma'am.
Okay, fine. So we will name this point as A, suppose. So we will take movement of all the forces about A must be equal to 0. We will start the equation. Now your N2 and F2 both are passing through point A. बरोबर?
Yes,
So
ma'am.
Yes.
movement will
Yes,
be
ma'am.
0. Okay, movement will be 0. Now movement of W2, which is 600 Newton, about point A, what type of rotational effect it will create?
Anti-clockwise.
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 Anti-clockwise. So you should write it with minus sign. It is minus 600 into. Now this perpendicular distance I require. I know that angle with vertical is 30 degree. So this is opposite to that. So can you tell me how much will be this distance?
60. Distance.
This is my hypotenuse, which is x. बरोबर? x है ना?
Yes, ma'am.
असा ट्रायंगल आहे माझा, असा ट्रायंगल. This is x. This is 30 degree. So what will be this distance?
X sin 30.
Yes, it is
X sin
x
Yes, ma'am.
sin of 30 degree. समजलं का हे सगळ्यांना?
Yes, ma'am.
Yes. Next force is W1, which is again about point A, create anti-clockwise rotational effect. So write with minus sign again. It will be minus. It is now 800, which is weight of the ladder, multiplied by. Can you tell me what will be this horizontal distance or this perpendicular
6 sin
distance
30.
now?
6 sin
It
30.
is simply 6 sin of 30. बरोबर का? सगळ्यांना समजतंय का?
Yes, ma'am.
Yes, ma'am.
Now your N1 is moving in the rightward direction. So about point A, it will try to create clockwise
Clockwise.
rotational effect.
Clockwise.
Yes,
बरोबर?
ma'am. Clockwise.
Yes. So it must be with plus sign. Value of N1 I will directly put 325.6 multiplied by. Can you tell me what will be this perpendicular distance? Angle
12
is
cos 30. 12 cos 30.
cos now,
Well,
because
cos 30.
this is, yes. So it will be 12 cos of 30,
Yes, ma'am.
and horizontal, sorry, this vertical F1, what type of rotational effect it will create?
Clockwise.
Again
Clockwise.
clockwise, so
Yes.
must be written with plus sign. And F1 is nothing but 0.3 होता ना वरचा आपला,
Yes,
Yes,
ma'am.
0.3
0.0.
into N1. N1 is 325.6. So this is total value of F1 multiplied by perpendicular distance is now
12 sine 30.
12 sine 30.
exactly 12 sine 30. This entire equation must be equal to 0 to keep the ladder in equilibrium. Can you tell me what value of x you are getting? Yes, काय आला आन्सर सांगा.
One minute.
काढताय?
2 minutes.
1 minute.
येस येस, हो हो, काढा काढा.
Five point two three.
5.23.
Correct. Whether all are getting same answer?
Yes, ma'am.
Is it clear to all? सगळ्यांना प्रॉब्लेम समजलं का?
Yes, ma'am.
Yes. आता हा एकदा बेसिक कन्सेप्ट आणि बेसिक पॅरामीटर जर कळलं की हाऊ टू अप्लाय 3 इक्वेशन्स, what is relation between these normal reaction and these frictional forces, mu can be different, this angle plays important role, weight of the ladder and weight of the person climbing on it is important, then any problem of ladder you can solve. Take down second problem. I will draw the figure first. It is given that a ladder is non-homogeneous now, and its centroid is, or center of gravity, is shifted from this bottom point to 2 meter distance. So at this point there is action of its self weight. हे मी आधी काढून देते तुम्हाला, मग प्रॉब्लेम रीड करते. दिस रिमेनिंग डिस्टन्स इज 2.5 मीटर. ॲज लॅडर इज नॉन होमोजिनियस, its center of gravity shifted. Now it is given that the wall is resting against, the ladder is resting against smooth wall. So this is important parameter at point A, and at point B it is supported by a floor. Mass of the ladder is 30 kg. And is concentrated at 2 meter from the bottom. Mu s between ladder and floor is given as 0.35. Will the ladder stand in 60-degree position? Okay. काय विचारलंय?
Theta.
थिटा दिलाय 60 डिग्री. विचारलंय की या गिव्हन पोझिशन मध्ये लॅडर स्टेबल असेल का, किंवा लॅडर स्टँड करेल का, की स्लिप डाऊन होईल. दिस इज पॉइंट ए, दिस इज पॉइंट बी. Can you tell me what we can do?
मैम वर्टिकल वॉल स्मूथ है ना,
काय बेटा?
वर्टिकल स्मूथ है ना म्हणजे वॉल.
हा, वॉल इज स्मूथ. येस.
लॅडर 30 kg आहे का वेट?
कुठलं बेटा?
लॅडरचं
लॅडरचं मास दिलंय, मास 30 kg. So what will be weight?
300.
30 into 9.81.
294.3. 294.3.
294.3 newtons. Okay. Draw the free body diagram first. मी याच डायग्राम मध्ये काढते, तुम्ही वेगळी फ्री बॉडी डायग्राम काढा. So there will be support reaction provided by vertical wall at point A. I will call this as N1 suppose, because I know that there is no frictional force offered by the wall as wall is smooth. So only one single reaction which is perpendicular to the vertical wall will be offered by the wall. Second is at this point it will receive some upward reaction, suppose N2, and the ladder will have tendency to slip in the outward direction. So obviously it will offer, or this horizontal floor will offer it a frictional force which is inward. Weight you have already calculated, it is 294.3 Newton. आता आधी प्रॉब्लेम समजून घ्या. What is asked? It is asked that this is the position where your ladder is standing. आता कुठलाही माणूस काही त्याच्यावर चढत नाहीये, काहीच नाहीये. But it is asked to find out whether in this situation, in this condition, with this angle of 60 degree, this ladder will stand or not. हे कशावर डिपेंड करेल मला सांगा जरा, की स्टँड करेल की नाही करणार, हे आपण कशाच्या भरोशावर काढू शकतो?
फ्रिक्शनल फोर्स जर ते लिमिटिंग पेक्षा कमी असेल तर.
Yes, exactly. It will depend entirely on the value of frictional force which is required for this position. जर या गिव्हन पोझिशन साठी माझा इथला रिक्वायर्ड फ्रिक्शनल फोर्स हा लिमिटिंग फ्रिक्शनल फोर्स पेक्षा लेस असेल तर डेफिनेटली लॅडर स्टँड करेल. पण जर आत्ताच्या या पोझिशन साठी रिक्वायर्ड जो काय फ्रिक्शनल फोर्स आहे तो जर जास्त असेल माझ्या लिमिटिंग फ्रिक्शनल फोर्स पेक्षा, ऑब्विसली लॅडर स्लिप डाऊन करेल. बरोबर की नाही?
Yes, ma'am.
So we need to check it for this position what frictional force I require to keep the ladder in equilibrium, and I need to find out what is my limiting frictional force. बरोबर का?
Yes, ma'am.
चलो करा solve. What will be your first equation? Again same way.
N1 is equal to F. म्हणजे
Yes.
F आणि
Summation fx will 0 will give me N1 is equal to F, which is my required frictional force, I will say. Okay. Go with summation fy is equal to 0. Your fy will give you N2 is equal to 294.3. बरोबर का?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes. Now I will take movement about which point? आता तुम्ही मला सांगा.
Point B.
B point.
Yes. I need to take it about point B so that I will directly get value of N1, which is nothing but my required frictional force. So I will take movement about point B so that F and N2 will create zero movement. 294 will create clockwise rotational effect. So write with plus sign. It is 294.3 multiplied by, what will be this distance? Can you tell me?
2 into
Horizontal.
cos 60.
2 into cos 60.
2
Ma'am,
cos
one
60.
less.
2 cos 60. बरोबर. And this horizontal leftward force will act and it will create anti-clockwise rotation. So it will be equal to, instead of writing with minus sign, I will take it on the right hand side. So it will be is equal to N1 into perpendicular distance of N1 with respect to this point B is, this is angle 60.
4.5 into sin 60.
4.5 into sin.
Exactly. 4.5 into sine of 60. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
Can you please find
Ma'am,
out any?
लॅडर स्लिप होती है.
बघू ना बेटा आपण.
नाही,
बघा
मी केलंय.
सांगा, नाही सांगा मला N1 किती आला.
मॅम 75.52 मॅम.
75 ठीक आहे. 51, 52
75.51. Yes,
Is
52.
it okay? आलं सगळ्यांचा आन्सर?
75.5.
Yes.
Yes, ma'am.
But can you tell me what is maximum frictional force or F limiting which can be offered by floor to your ladder?
Ma'am,
It is
US into N2.
correct.
into
It is
N2.
US into N2. Okay. N2 is 294.3 and mu is given as 0.3. Can you tell me what available force you are having?
Ma'am, 103.005.
88.29 येते मॅम.
88.29.
Yes.
88.29.
Yes, ma'am.
किती येते? 88.29.
29.
0.35 into 294.3 करा. माझ्याकडे
हा, correct.
आन्सर हे आहे
Correct,
103.
Correct.
मॅम 0.3
Yes.
पण आहे का? 3 आहे.
0.35 आहे.
0.35 आहे.
0.35 दिला आहे ना?
हा 103 point.
3.0.
Okay, yes. So now your available, which is F limiting, is, and this is your required frictional force. Which is more? This is your required frictional force because you know that N1 is equal to F required, and this is your available force. So obviously your available force is
Greater.
more as compared to your required force. So whether ladder will slip?
No ma'am, it will not slip.
It will not slip.
No, it will not slip. कोणाचा आन्सर चुकीचा आलं तरी आता मला कोणीतरी सांगितलं.
माझं आलं होतं मॅम चुकीचं.
आता आलं का बरोबर?
हा,
कळलं
आलं.
का?
कळलं.
येस. ओके. बरं सगळ्यांना समजलं का प्रॉब्लेम? इज इट
मॅम
क्लिअर?
एकदा एफ रिक्वायर्ड आपण कशाला कन्सिडर केलं एकदा ते सांगा ना.
हे बघ, एफ रिक्वायर्ड म्हणजे तो फ्रिक्शनल फोर्स आहे जो आत्ताच्या ह्या पोझिशन साठी या सिस्टीमला इक्विलिब्रियम मध्ये ठेवण्यासाठी आपल्याला लागतोय.
ओके.
आपल्याला असं माहिती नाही की हा एफ किती फोर्स आहे. आपण असं म्हणू शकत नाही की मला लिमिटिंग फ्रिक्शनल फोर्स या पोझिशन साठी लागतो. नो, मी असं म्हणेन की हा अननोन फोर्स आहे जो मला ही सिस्टीम किंवा ही लॅडर या पोझिशन मध्ये इक्विलिब्रियम मध्ये ठेवायला, या हॉरिझॉन्टल नॉर्मल रिएक्शनला बॅलन्स करायला इथे लागतो. बरोबर? मग आता एकदा मी ही रिक्वायर्ड व्हॅल्यू काढल्यावर मला माहितीये की एवढ्या हॉरिझॉन्टल फोर्सची मला रिक्वायरमेंट आहे. बट माझ्याजवळ अवेलेबल किती आहे? माझा हा सरफेस किंवा हा फ्लोअर जितका मॅक्सिमम फ्रिक्शनल फोर्स या लॅडरला ऑफर करू शकतो तो माझा एफ लिमिटिंग फोर्स असतो, विच इज म्यू एस इंटू N2. So that will be my available force and this is my required force. If requirement is less than availability, obviously it will remain in this position. बरोबर का? हाच जर माझा एफ रिक्वायर्ड मोर आला असता आणि एफ लिमिटिंग लेस असता तर मला असं म्हणावं लागलं असतं की एफ लिमिटिंग इज नॉट सफिशियंट टू कीप द लॅडर इन स्टेशनरी पोझिशन, इट विल स्लिप डाऊन. कारण माझं रिक्वायर्ड फोर्स एवढा आहे. पण आता या केसमध्ये तो रिक्वायर्ड कमी असल्यामुळे लॅडर विल स्टँड. इज इट क्लिअर?
ओके मॅम.
Yes ma'am. मॅक्सिमम फोर्स नाही लागत म्हणजे जेवढा रिक्वायर्ड असतो तेवढाच लागतो.
येस येस डेफिनेटली येस. म्हणून त्याला आपण लिमिटिंग फ्रिक्शनल फोर्स म्हणतो. आपण इतर वेळी कोणत्याही गोष्टी सॉल्व्ह करताना जेव्हा आपल्याला हे माहिती असतं की आता ह्या पोझिशनला तो स्टेशनरी आहे पण पुढच्या मुवमेंटला तो डायनॅमिक कंडिशन मध्ये जाऊन स्लिप डाऊन होऊ शकतो, तेव्हा आपण एफ लिमिटिंगची कम्प्लीट व्हॅल्यू वापरतो म्यू इंटू एन करून. बट जिथे आपल्याला चेक करायला सांगितलंय की या पोझिशनला तो राहील का, याचा अर्थ त्या पोझिशनला रिक्वायर्ड फ्रिक्शनल फोर्स हा कमी पण असू शकतो किंवा जास्त पण असू शकतो. मग मला एफ लिमिटिंग सोबत त्याला कम्पेअर करून आधी हे चेक करावं लागेल की तो स्टेशनरी राहील की तो मोशन मध्ये जाईल. ठीक आहे?
येस
येस मॅम.
येस. ओके. आता एक प्रॉब्लेम देते, ते मला सॉल्व्ह करून दाखवा. बरं, लॅडरचं घ्यायचं प्रॉब्लेम आता की रिव्हिजन करायची ते पण मला सांगा, कारण लॅडरची एवढी इन्फॉर्मेशन माझ्या साईडनी तरी सफिशियंट आहे.
रिव्हिजन.
रिव्हिजन मॅम. रिव्हिजन.
ओके. बरं, आता रिव्हिजन साठी काही कुठला स्पेसिफिक टॉपिक रिवाइज करून हवाय का ते सांगा, नाही तर मग मी फ्रॉम स्टार्ट टू एंड सगळी थेअरी रिवाइज करते.
मॅम
काय
सगळीच करा
करायचं?
मॅम.
मॅम म्हणजे जे एमसीक्यू साठी तुम्ही इम्पॉर्टंट वगैरे सांगितलेले ते सगळे पॉइंटर्स वगैरे सगळे सांगून द्या.
बरं, सगळं सांगते. चलो. So we will start with our very first unit, which is related to all type of force system. So always remember that whatever forces we have dealt under unit number 1, all were coplanar forces. Coplanar forces are divided into 3 categories, where all the line of action for forces intersect at one single point. It is known as concurrent coplanar force system. When all the lines are parallel to each other, it is known as parallel coplanar force system. And when the lines are not parallel nor they are meeting at one single point, it is known as general coplanar force system. So initially we have started with finding out resultant for all 3 type of force system, where we know that in case of concurrent we are having only 2 equations. For that we use principle of resolution and composition. So in case of resolution, our first step is whatever inclined forces are there, we need to resolve them into 2 perpendicular components. Every inclined force we need to resolve as per its quadrant, and accordingly I will go for summation fx as my first step, which will give me plus or minus value, summation fy as my second step, which will again give me plus or minus value, and according to the sign of my summation fx and fy, I will decide quadrant of my resultant. Magnitude I can find out because I know that summation fx is nothing but x component of resultant, summation fy is nothing but y component of resultant. So I can say that my r will be equals to under root of rx square plus ry square. This will give me magnitude of resultant in Newton. Quadrant I have decided. I need to find out what is that resultant, which is theta. We know that it is tan inverse of, here in this case, as we are following quadrant system, we take it as tan inverse of mod of fy by fx, or you can say ry by rx, or summation fy by summation fx. Is it clear?
Yes, ma'am.
So that your theta in case of quadrant system, or you can say coplanar force system, is always less than 90 degree. This is regarding concurrent coplanar force system. In second force system, we can skip any one equation. If the forces are along y direction, I can directly say that summation fx will be equals to 0. I need not to apply this equation even. I will go with my second equation, that is summation fy. I can say that whatever sum I will get, it will be nothing but ry, which is nothing but r. Depending on upward or downward sign, or you can say sign plus or minus, I will decide what is direction of resultant. Once I will get magnitude of resultant and its direction upward or downward, I have to locate the resultant on my given frame or member or beam by using which theorem?
Varignon.
Varignon's theorem.
Varignon's theorem. Okay. So Varignon theorem can give me location of the resultant with respect to any point, left hand point or right hand point, anyone. So mathematical expression is algebraic sum of movement of all the forces about any point in the given plane must be equal to movement of resultant about same point. This is mathematical expression. Now, general coplanar force system is combination of concurrent as well as parallel. Because we know that no force or their line of actions, they are scattered or they are not intersecting or meeting at one single point, nor they are parallel to each other. So we need to first go for all the inclined forces I need to resolve into perpendicular components. I need to calculate the summation fx. I will go for summation fy. Again, from these two, I will find out magnitude of r as under root of rx square plus ry square. Depending on their plus or minus sign, I will decide quadrant of resultant. I will again find out theta, which will be tan inverse of fy by fx. Once I will get all these parameters which are part from concurrent, I now apply Varignon's theorem, yes, for calculation, or you can say for location of resultant. I will locate this resultant with the help of Varignon. Again, same principle I will apply. So general force system is always combination of concurrent and parallel coplanar force system. After this, we have seen that if this is the part when it is asked to calculate the resultant, but when we deal with equilibrium of these same three type of force systems, we know that simply whatever equations I was using for concurrent, I will equate them with 0, because I know that if ultimately my resultant is 0, my summation fx as well as summation fy must be equal to 0. But this is not the case applicable for parallel force system, because even if my summation fx is 0, if all the forces are along x direction, or it can be a case that summation fy is equal to 0 if all the forces are along y direction, I cannot say that, I cannot conclude that my system will be in equilibrium. I need to check with my third condition of equilibrium, which is movement of all the forces about any point is equal to 0 or not. Because if I will not get such kind of value, I can conclude that my parallel forces are forming some kind of couple, okay, which is having some magnitude f and perpendicular distance d because of all the upward and downward parallel forces acting on the system, and because of which my body or member will not have tendency to remain stable, because upward f is cancelling downward f. Translational effect is 0, but because of this kind of couple, there will be chances of rotation about third perpendicular axis in the system. So I need to check for this. So this is my important condition which I need to apply for equilibrium parallel forces to check whether the system is in equilibrium or not. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
Yes. Third type of force system is general force system. So in this case, again combination of this and parallel. So again, here it was or. Either summation fx किंवा summation fy एकच इक्वेशन अप्लाय होतं. But in case of general, again we need to apply all three conditions, that is summation fx must be 0, summation fy must be 0, so that ultimately r will be 0. But this is regarding translational motion. I need to check its rotational effect, so I need to apply summation of movement of all the forces about any point must be equal to 0. इथपर्यंत सगळ्यांना आठवतंय का?
Yes, ma'am.
Yes, ma'am.
Yes. Now in case of beams specifically, we will start with two forces. So if any point I want to keep in equilibrium, which is acted upon by only two number of forces, those two forces must be collinear. They must be of equal magnitude and their direction must be opposite, so that they can keep the system in equilibrium. This is action of two forces. When I talk about action of three forces, obviously, which theorem I can apply? Can you tell me? आठवतंय का?
Lammy's theorem.
Lammy's theorem.
Correct, Lammy's theorem. So Lammy's theorem is applicable in case of equilibrium of three forces. When three forces are acting, either I can consider them as three forces which are coming towards the joint, or they are going away from the joint and they are keeping the joint in equilibrium. So these condition we can use our sine rule. Sine rule आठवतोय सगळ्यांना?
Yes, ma'am.
Yes.
Any three forces and opposite angles. So suppose it can be F1 by sine of alpha, F2 by sine of beta, and F3 by sine of alpha gamma. Is it clear? These are the opposite angles. Angle between alpha will be angle between F2 and F3, beta will be angle between F1 and F3, and gamma will be angle between F1 and F2. आठवतंय? Clear?
Yes, ma'am.
Yes.
Yes, ma'am.
So this is equilibrium of two forces. This is equilibrium of four forces. But when we deal with equilibrium of more than three forces, we need to go with summation fx is 0 and summation fy is 0. No other alternative. ठीक है?
Yes, ma'am.
Okay.
Yes.
Yes. Yes, ma'am. Then we have seen, if suppose two forces are acting on a particle, you can find out their resultant. You can apply some principle which can give you some unknown parameters. As this is concurrent force system, obviously any time you can find out at the max two unknown parameters. So for these two forces, if I want to find out resultant, can you tell me how many ways are available? By how many possible ways I can calculate it?
Parallelogram law.
Parallelogram law, triangle law,
Law of parallelogram and
triangle.
Resolve
Triangle.
करून
triangle law.
triangle
Correct.
law. Triangle law.
Okay. So if I am talking about triangle law, then I can say that this is F1, this is F2 with some angle theta. There will be effect of F2 first, then there will be effect of F1 which is having angle theta. Then resultant will be, these are the two sides, adjacent sides of a triangle taken in order. Then my resultant for the given force system will be a force which is directed or which is having opposite order. It will represent magnitude and direction of the resultant, which is closing side of my triangle. Barobar?
Yes, ma'am.
This is one way.
Yes, ma'am.
Or you can say that these same two forces, if they are acting as two adjacent sides of a parallelogram, and if I will complete this parallelogram, then the diagonal which is starting from the intersection point of two forces will represent resultant of the given force system, both in terms of magnitude as well as a direction. Here in this case, I need to apply two formulas. R will be equals to under root of, yes,
F1 square plus F2
F1 square plus F2
2F1
square
F2 cos
plus
theta.
2F1 F2 cos theta.
Cos.
बरोबर?
Yes, ma'am.
Yes, ma'am.
If I want to find out angle alpha, that is angle of resultant with respect to first force F2, it will be tan inverse of, yes,
F2 sin theta upon
F1 sin
it
theta.
will be F1, this is P.
F1.
F1.
So it will be
F1.
F1 sin of theta plus F2 plus,
F2 plus F1 cos theta.
F1 cos theta.
बरोबर? आठवतंय
Yes,
सगळ्यांना?
ma'am.
सो
Yes,
नोटेशन चेंज झाले म्हणून आपला फॉर्म्युला चेंज होत नाही. जर लॉजिकली फॉर्म्युला नीट लक्षात ठेवला तर कुठलेही पॅरामीटर किंवा कुठलंही नोटेशन दिलं तरी आपल्याला आपला फॉर्म्युला नीट लिहिता आला पाहिजे.
Yes, ma'am.
So by using triangle law or by using law of parallelogram, you will be able to find out resultant and its direction. आता इथे थीटा नाही म्हणत मी, अल्फा म्हणूया वाटलं तर, and its angle or direction when two forces are given. ठीक आहे? आठवलं सगळ्यांना?
Yes, ma'am.
Yes, ma'am.
Next to it was application of triangle law. Where we apply triangle law, can you tell me? आठवा जरा. अप्लिकेशन ट्रायंगल लॉ कुठे यूज करतात? एनीवन अभ्यास केलाय का? येस बेटा.
मॅग्निट्यूड सेम असेल तेव्हा
कशाची मॅग्निट्यूड बेटा?
दोन फोर्सेस दिले असतील तर.
नो, असं काहीच नाहीये. वेगवेगळ्या मॅग्निट्यूड साठी पण आपण अप्लाय करू शकतो.
नॉन परपेंडिक्युलर रिझोल्यूशन.
Exactly. When some force is given and we don't want its resolution in perpendicular components, but instead of that it is asked to resolve the given force into two non-perpendicular axes, suppose A dash and B dash, then we know that this force will have one component along BB dash and one component along AA dash, which is non-perpendicular to each other. बरोबर का?
Yes, ma'am.
So here we will use our law of triangle. What we can say? We can consider this as BB dash, then action of AA dash. This is your first component. This is your second component. And my parent force will be like this. Is it clear? See the order of forces. Two forces taken in order. This is closing side of triangle taken in opposite order is nothing but resultant. So you can consider your law of triangle as, in this case, non-perpendicular resolution as one single force can be resolved into two non-perpendicular components, or I can say that these two non-perpendicular components are parent forces and their resultant is this force F. आठवतंय सगळ्यांना?
Yes, ma'am.
Yes.
So if I will know angle between these force F and one of the component and this parent force and angle with second component, then it means that I have this angle, that is main force and one component and main force and second component. By using this value, we can find out what will be this remaining angle and I can apply sine rule. बरोबर का?
Yes, ma'am.
सगळ्यांना आठवतंय?
येस मॅम.
केला का अभ्यासाचा? ज्यांनी केला असेल, ज्यांनी थोड्या जुन्या नोट्स पाहिल्या असतील, नाही तर मग आता बरेच दिवस झाले म्हटल्यावर विसरू शकतात.
Yes, ma'am. केलं.
ओके, सो हे प्रॉब्लेम एकदा बघून ठेवा. इम्पॉर्टंट प्रॉब्लेम, MCQs. अशा टाईपचं प्रॉब्लेम येऊ शकतं 2 मार्कांसाठी कंपोनंट काढायला. ठीक आहे का?
Yes, ma'am.
Yes,
चलू
ma'am.
पुढे.
Yes, ma'am.
Yes. Next was, we have seen problems related to beams. So type of beams I have studied. काय काय शिकली मी सांगा? कुठल्या कुठल्या टाइप ऑफ बीम शिकवल्या सांगा जरा. याला कोणती बीम म्हणतात?
Simply supported beam.
Yes, it is simply supported beam. If I will extend some portion on left or right side, काय म्हणतात या बीमला?
Overhanging.
Overhanging.
Okay. If suppose I will provide more than 2 supports to this beam, काय म्हणतात याला?
Continuous.
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 If one end is fixed and other is free, काय म्हणतात याला?
Cantilever.
Cantilever.
Beam. बरोबर? So all these are the type of beams. Then type of support. First is your simple support, which is used in simply supported beam. Second is roller support. आता आपण भरपूर प्रॉब्लेम सॉल्व्ह केले, त्याच्यामुळे आता रोलर सगळ्यांना नीट कळालंय. रोलर सपोर्ट काय असतो, काय करतो रोलर, सांगा मला जरा. रोलर
Perpendicular to the
प्रोव्हाइड्स,
surface reaction.
Compression.
Single perpendicular force.
it simply provides one support reaction which is perpendicular to the plane on which roller is resting. If your roller is resting with the help of vertical wall, your support reaction will be horizontal. If the roller is inclined with some surface perpendicular to it, will be its support reaction. If roller is resting on horizontal plane, vertical will be the support reaction. Is it clear? So roller always provides one single reaction which is perpendicular to the plane on which roller is resting. Okay?
Yes, ma'am.
Next type of support is hinge support. Hinge can also be inclined. It can be resting with on vertical or horizontal plane. But in any case, what is restriction offered by hinge?
Two reaction forces, horizontal and vertical.
It always restricts horizontal and vertical support, or you can say it always restricts horizontal and vertical translational motion of that particular end. What it allows? तो allow काय करतो सांगा मला?
Rotational motion.
Rotational
Yes,
motion.
it allows rotational motion of the member. Best example was door hinge. Some internal hinges are also there, which are known as pin supports, but they are internally provided in the members, and they will be again giving same kind of support. That is, they will not allow any kind of translational motion with respect to each other, but it can allow rotation for these arms. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So these are the types of supports. One more is there, that is fixed support. So fixed support is having this kind of indication. It will restrict everything. It will not allow any kind of translational motion along horizontal or vertical direction. And along with that, it will also restrict rotation of this end. It will not allow to rotate this end from this point. Is it clear? So there are three reaction components for fixed, that is horizontal, vertical, and fixed end movement. आठवतंय का?
हो मॅम.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So these are the type of supports. Next we have seen in unit number 1 is type of loadings. So loadings are of 3-4 types. This is known as point load or concentrated load, which acts only on one single point. That is, point of application is one single point or unit area. That is known as point load or concentrated load. Always remember that for analysis of any kind of structure, we convert all other type of loadings into point or concentrated loads, and then only we can solve that problem. बरोबर? बरोबर?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
If suppose some UDL is provided in the structure, which is suppose W Newton per meter intensity, which is acting on L meter span, you can convert it into point load just by multiplying intensity multiplied by span, which will act exactly at the center of span, that is L by 2, L by 2. Barobar? This is converted point load. If it is acted upon by some triangular load, then we need to find out area of this triangle, which is suppose base L and maximum intensity W Newton per meter. Then we need to find out this area, and we need to act it from this base point, that is right angle triangle जिथे फॉर्म होतो त्याला बेस म्हणतो आपण. From this point at the distance of L by 3 or base by 3, your converted point load will act, which will be nothing but half base into height, which is area of a triangle. आठवतंय?
Yes, ma'am.
Yes. And lastly, same triangular load can also be asked in the problem as UVL with trapezoidal load. Here in this case, lower portion we will separate out. We will consider this as UDL of intensity W1, and this will be suppose W2. So for remaining triangle, it will be W2 minus W1 as height, and we will consider this triangle as separate load and this rectangle as separate load. For this rectangle, if it is span of L meter, your converted point load will act exactly at the center of span, which is L by 2 and L by 2. And this converted point load will be W1 into L. That is my intensity. And for triangle whose converted load will be from this base point, that is 90-degree angle, it will be at a distance of L by 3, that is base by 3, or from this point it will be 2 by 3 of L, and there will be action of converted point load. This converted point load I will write with blue color. This will be half, base is L and height is W2 minus W1 in this case. Is it clear to all? सगळ्यांना आठवतंय?
मैम आपने अभी जो ब्लू वाला पार्ट किया ना मैम, एक बार रिपीट कर दीजिए ना मैम.
कौन सा? ये ब्लू वाला?
आपने यस मैम, आपने किया ना मैम, हाफ इंटू एल इंटू W2 माइनस W1 वाला.
आपका अपर ट्रायंगल अभी क्या साइज का बचा है? फॉर दिस इज W2 माइनस W1.
एरिया है ना मैम वो.
हाँ, तो ट्रायंगल का एरिया, यस, ट्रायंगल का एरिया ही हमें कैलकुलेट करके उसके सेंट्रॉइड पे एक्ट करवाना पड़ेगा. So this will be, if base is L, then this will be 2 by 3 of L, and this will be L by 3 from this base point, and converted point load will be half area of this triangle. Base is L and height is now W2 minus W1, because W1 तक का पोर्शन आपने UDL के लिए कंसिडर कर लिया. So बचा हुआ क्या है? W2 minus W1 as height of triangle. Is it clear? आठवतंय का हे सगळ्यांना?
Yes, ma'am.
यस मैम.
Yes, ma'am.
Yes, ma'am. Okay, done. चलू पुढे.
Yes, ma'am.
Then there was couple, or you can say movements. Movement आणि couple मध्ये difference आहे, पण movement can be formed by single force which is having some perpendicular distance with respect to your movement center. It will create clockwise effect, or depending on location, depending on this distance, your movement value can change. If you will change the magnitude of force, or if you will change your movement arm, your movement of that particular force about given point will change. But this is not the case with couple, because couple is action of two parallel forces which are having same magnitude and separated by perpendicular distance. So they are having some effect of rotation about third perpendicular axis which is coming towards you. So couple is, force is a sliding vector. You can slide it anywhere on its line of action, law of transmissibility. Movement is, this is force. Movement is what type of vector? Fixed vector. Because you cannot, yes, because you cannot change your D or magnitude of F. Only this position and this movement arm can give you this value of movement of any force about any point. If you will change distance D or change value of F, value of movement will change. Even effect can be changed. Sense पण change होऊ शकतो. Rotation clockwise or anti-clockwise होऊ शकतं. But in case of couple, couple is known as what type of vector?
Free vector.
Free vector.
Free vector.
You can consider this couple anywhere on the given member. You can change its angle. या दोन parallel forces चा मी असा दोन parallel forces काढले तरी फरक पडणार आहे का त्याच्या couple value मध्ये?
No, ma'am.
No ma'am, no.
No. So in any case, even if you will change its position, even if you will change direction of these two forces, anything you can do with this couple, but its magnitude will remain same because it is always one of the force multiplied by perpendicular distance. So this is very important concept. Next to it is, yes beta.
कपल मध्ये लाईन ऑफ ऍक्शन पण नेसेसरी नाही आहे ना.
लाईन ऑफ ऍक्शन पॅरललच असते ना दोन्ही फोर्सेसची, त्याच्यामुळे त्यातलं परपेंडिक्युलर डिस्टन्स डी मॅटर करतं आणि एखाद्या फोर्सची मॅग्निट्यूड दोन पैकी. म्हणूनच आपण त्याला किती डिग्रीनी रोटेट केले कपलचे दोन पॅरलल फोर्सेस तरी पण कपलची मॅग्निट्यूड नाही चेंज.
ओके.
ओके, येस, दॅट्स वाय कपल इज फ्री वेक्टर. कॅन यू जस्ट टेल मी व्हॉट इज अप्लिकेशन ऑफ कपल? का बरं वापरतो आपण कपल? आठवतोय का जरा काही? कुठे वापरलं होतं कपल? प्रॉपर्टी काय आहे कपलची?
चेंज करायचं असेल तर
If we want to change location of our parent force from its initial position to any new position, I can use this property of couple, which is known as equivalent force couple system. आठवतंय का सगळ्यांना?
येस मॅम.
Yes, ma'am.
So in that case, what I do? First step is take my force as it is, place it to new position, and take movement of my original force about new point. So obviously it will give clockwise rotation. Obviously clockwise movement येणार आहे म्हणून. So this force will be as it is F, and this will be movement of force taken about this point B. If I will take this as D, त्याचं meaning असं आहे की माझ्या दोन फोर्सेस मधलं परपेंडिक्युलर डिस्टन्स D आहे. Is it clear?
Yes, ma'am.
Yes, ma'am.
येस मॅम.
Okay. If it is not possible for me to take movement of this inclined force, better you resolve the inclined force at its point of application according to its quadrant and take movement of these two components instead of one single force. Take that movement about new point. You will get same value. Is it clear?
Yes, ma'am.
Yes, ma'am.
So this is equivalent force couple system. So this is all about unit number 1. काही आहे का युनिट नंबर 1 मधलं जे सुचल्यासारखं वाटतंय?
No, ma'am.
नो मॅम.
ओके, येस, फाईन. आता बर्कन युनिट नंबर 2 मध्ये जे जे काय शिकलो ते एकदम फास्ट सांगते, कारण मला परत 4:30ला दुसऱ्या डिव्हिजनला लेक्चर आहे. सो इफ सपोज फर्स्ट वी हॅव डील्ड विथ व्हॉट टाइप ऑफ, आय गेस वी हॅव स्टार्टेड विथ ट्रसेस, बरोबर? सो इन केस ऑफ ट्रसेस, so trusses नेहमी लक्षात ठेवायचं, they are formed by strut members which are slender and their weight is negligible. We neglect weight of those slender members. Trusses, we are having perfect or imperfect trusses, or you can say determinate or indeterminate trusses. The meaning is that m equals to 2j minus r equation must be satisfied. If this is satisfied, then it is perfect truss. Okay. What is M stands for?
Member.
number of members.
Members. A stands for
Joint.
joint. R for reaction component.
Reaction component.
Okay. So if this M equals to 2j minus r, it is perfect truss or determinate truss. But if M is more than 2j minus r, सांगा मला टाइप ऑफ ट्रस काय म्हणतो आपण त्याला? Yes. Redundant truss. Okay. If M is less than 2j minus r, हे तर काय एकदम deficient truss. बरोबर? So it's very important. MCQs मध्ये याच्यावर पण बेस्ट प्रॉब्लेम येऊ शकतं. काही दिलं असेल मेंबर, फोर्सेस, एखादी डायग्राम, and it will be asked whether to check what type of truss is this. So you need to calculate. Next is, we are having two methods for trusses, joints and section. Particularly when joints is asked, you need to analyze entire truss जिथे विचारला असतो. Okay, so entire truss is expected to be analyzed. We will use method of joint. Joint मध्ये काय करतो? आधी आपण conditions of equilibrium apply करून ट्रसेसच्या support reaction find out करतो, and then we isolate one by one all the joints of trusses, and at every joint there will be formation of some concurrent force system where you can apply our equation of summation fx is 0 and summation fy is 0. Initially, when we assume any point, any joint, and we draw some forces on that joint, initially assume that all your members are carrying tension. If we will get plus value, it means that our assumption is correct. If we will get minus value, our assumption is wrong. Member is not in tension, it is in compression. So that when you will draw the same member for any other new joint, then at that time don't draw that member in tension because already you have calculated that it is in compression. Is it clear?
Yes, yes.
Yes. Second one is method of section. In case of method of section, some specific members are expected to be analyzed. In that case, only we will go for method of section. So section we will consider in such a way that two conditions are there. Your section must not cut more than 3 unknown members. Barobar? Okay, so max 3 unknown members it can cut. And second is on either side of the section, minimum, you can say 2 minimum joints should be there. Because we know that when we take a section, we can directly use equation of movement, take movement about this joint, take movement about that joint, and you can directly find out forces in the unknown members. आठवतंय सगळ्यांना?
Yes, ma'am.
Yes. Next was cables. Cables मध्ये काय शिकलो? Cables are normally having two hinge supports. So that way it is indeterminate structure. But we know that one of the point whose sag is known to us with the help of our principle that as entire cable is in equilibrium, isolated part of the cable will also be in equilibrium. Considering that part, we can find out horizontal reactions and vertical reaction components of the cable. आता मी इथे डिटेल मध्ये काढत नाहीये, परत ते गो थ्रू करा, नोट्स पाठवल्या त्याच्यात आहे. ठीक आहे? Okay. The most important parameter of cable, when this is your cable structure, always remember that the segment which makes maximum angle with respect to horizontal सोबत ज्या केबल सेगमेंटचा अँगल जास्त त्या केबल सेगमेंट मध्ये मॅक्सिमम टेन्शन असतं. Mostly that 99% or 100% your maximum tension is either in this first segment or in this last segment. Okay, so always find out this angle with respect to horizontal. जो segment maximum towards vertical असतो, म्हणजे त्याचा angle with respect to horizontal हा जसा जसा वाढत जातो तसा तसा तो vertical होतो आणि vertical मध्ये त्याच्यात maximum tension असतं. Because we know that sine of this angle is nothing but sine 90, which is 1. बरोबर का?
Yes, ma'am.
So हे हा क्रायटेरिया लक्षात ठेवा की मॅक्सिमम टेन्शन केव्हा असतं जेव्हा तुमच्या सेगमेंटचा अँगल विल हॉरिझॉन्टल मॅक्सिमम असतो. This is regarding cables. Then we are having space forces. So in case of space forces, two type of problems are there. Concurrent and parallel. So in case of concurrent, resultant find out करायचं आहे. In parallel resultant find out करू शकता. In case of parallel, again same way, varying on you need to apply and locate the resultant. In case of concurrent, you need to write unit vector. Your force in vector form as force magnitude multiplied by unit vector. So this is most important part from concurrent forces. जर तुम्हाला मला force unit लिहिता आला तर कुठलेही 4, 5, 6 किती स्पेस फोर्सेस होऊ द्या त्यांचा रिझल्टंट इज नथिंग बट युनिट वेक्टर आणि या मॅग्निट्यूड बरोबर जे काय आय येतात त्या सगळ्यांची सम प्लस सगळ्यांची सम आणि सगळ्यांची सम. सगळ्यांचे कोऑर्डिनेट पण नीट लिहिता आले पाहिजे. ऑलवेज डोक्यात असं फिक्स करून पकडून ठेवा. The point where all the forces are meeting, that point of concurrency we always take first point or starting point of the force, and this always should be second point of force, so that you can write this as x2 y2 this as x3 y3 z3 पण प्रत्येक याच्यात कॉमन तुमचा हा x1 y1 z1 आला पाहिजे. So point of concurrence and नेहमी force ला starting point consider करायचा by writing your unit. And then whatever you get, just sum up I, J, and K, so that will give you value of Rx, value of Ry, and value of Rj. Is it clear?
Yes,
Is it clear?
Yes, ma'am.
In case of phase forces, your resultant will make different angles with all the axes. No connection between these angles. फक्त एकच कनेक्शन आहे. काय? तर cos square theta x plus cos square theta y plus cos square theta z हे 1 असणार. एवढे एकच रिलेशन. But बाकी हा कशाने काढायचे? It will be whatever magnitude you will get as r under root of rx square plus ry square plus rz square नी जी magnitude येईल आली. This magnitude and these are components will be used to find out theta x, that is cos inverse of r by r. Same way cos inverse of ry by r, cos inverse of rz by r. If sin is plus for rx or ry or rz, then your angle theta x will be less than 90 degree. But if sin of this is when fx is positive. But when your horizontal axis of Rx, but when your Rx is negative, you will get your theta is value more than 90 degree. Because we know that in case of phase forces, we take angle of any force with respect to positive x, positive y, and positive z. Right?
Yes, ma'am.
Okay. त्याच्यानंतर पॅरलल सांगितलं तर पॅरलल कसं व्हायला लावतो ज्या डायरेक्शनला पॅरलल फोर्सेस आहे त्या डायरेक्शनला त्यांचे सम करायचे सम जी काय व्हॅल्यू प्लस और मायनस ती कन्सिडर करायची मॅग्निट्यूड आणि प्लस असेल तर अपवर्ड डायरेक्शन मायनस असेल तर डाउनवर्ड डायरेक्शन and simply we will apply varying non-bounding case of x-axis, that is algebraic sum of movement of all the forces above x-axis must be equal to movement of resultant above x-axis. Is it clear?
yes, ma'am.
Yes, ma'am. सगळ्यांना असं मला वाटतं मी पाचमध्ये डिवाइस करून दिलेला आहे तरी आधी काय लास्ट यामध्ये अभ्यास करायला तेव्हा आपण काय डाटा आवश्यक की फाईलवर मी शेअर करून सांगितलं बट काय जे काय डाटा आवश्यक ते मला व्हॉट्सअपला विचारा. ठीक आहे?
Yes, ma'am.
Just give me attention कारण आपला रेग्युलर क्लिअर म्हणून करते आणि क्लास आपल्याला मला चेन्नई खूप करायला लागणार आहे. So just give me a second for days. Actually किती आहे 3 दिवसा.
Yes, ma'am.
Yes.
नंबर 1 2 दिवसात मी मला आला आपण परत 3 4 5 6 6.9 7 8
Present, ma'am.
9 10
Present, ma'am.
11 11 13 14
Present, ma'am. Present, ma'am.
15 16 17 18
Present, ma'am.
Present, ma'am.
19 20
Yes, ma'am.
21 22 20 24 दोन्ही सत्तर मला आला 25 26 25 गेला रमेश आर यू देयर yes 21 not there 28 29 30 31
Present, ma'am.
Ranjit are there 31 there. Roll number 32. 34, 35.
Present, ma'am.
36, 37. 37, 38, 27 नहीं है. 39, 40.
Present, ma'am.
41, 42.
Present, ma'am.
43, 44.
Present, ma'am.
45 is not there. 46. Yes. 47, 48, 49.
Present, ma'am.
Present, ma'am. 50.
Present.
51, 53, 54. Yes, 55, 54, 55, 56.
Present, ma'am.
Yes, 57, 58, 29.
Present, ma'am.
Yeah. 59. Vedan, are you there? 60 is not there. 61, 62.
Present, ma'am. Present, ma'am.
63 is not there. 64, 45.
Present, ma'am.
66, 67.
Present, ma'am.
68, 69.
Present, ma'am.
70, 71.
Present, ma'am.
71, 72, 73.
Present, ma'am.
74.
Present, ma'am.
Yes, all numbers are 2, 6, 20, 24, 27, 32, 37, 38, 45, 47, 51, 52, 54, 58, 60, 63, 71, and 73. Yes, काय आहे रे काय आहे अच्छा फाईन ठीक आहे बाय माझं सेकंडला ऑर्डर ते आणि लाईट आउट तर मला म्हटलं येस बेटा
मॅम आपण
हाँ yes I will send it yes by today evening I will send that okay आता like I class में कोई other अपने WhatsApp group पे okay yes चलो bye take care all the best चलो
ma'am.